Logarithms. Okay, so now we are trying to do something that's pretty serious, tough. That's like the kind of sound that you should be making when you start learning logs. Okay. Right, so what is a log? Well, I know that other people give different definitions, but there's a definition that I like to give, which is somewhat different from other people, but you'll see that it works. Okay? So what's a log? Log is something that cancels with the exponential function. So a and log a gives you this, and log a of x gives you this. A little bit of word about where this definition comes from. This definition is really, all it's saying is that this is really saying, i.e., f of x equals to a to the x, and f inverse, no, g of x equals to log base a of x are inverses of each other. Because there's a property that inverse functions enjoy. If you have f composed with its inverse function, like that, they cancel to give you x. And if you compose f inverse with f, they cancel to give you x. That's the property of an inverse function. And although this is a property of an inverse function, there's a theorem that says any function, let's say g of x, that satisfies these two cancellation rules, if f of g is x, f of g of x is x, and g of f of x is x, if these two things are satisfied, in other words, if these two things cancel, then these two are inverses of each other. That's a theorem. That's a mathematical theorem. Okay. So I could have said, in the beginning, I could have said, what's a logarithm? It's the inverse function of this function, and nobody will have any idea what that means. Okay, yeah. That's why I don't like this type of introduction. Okay, the way I like to introduce log is that it's something that cancels. You have these two cancellation rules, and because these two cancellation rules capture the very idea of this being inverse of that function, it basically you get everything. And plus, by this definition, you can easily compute. Right? So that's where all this definition comes from. If you don't like all these theorems, you can just ignore what I just said and just come back to this thing. Okay. So all good? It's just something that cancels like that. Easy, right? Okay. All right. Now let me. Yeah. You have a question? Okay.
Just plug in the
Right. Log base of a of x. Some calculators have that as a function. Many calculators, however, they only have this as the function. And if you don't have anything, that means by definition 10 is down here. Okay. So okay. So maybe I should have some word about calculators. On calculators, there are two types of logs, log without anything, and there's another one called ln of x. These are both these types of functions, log a of x, and log of x is log 10 of x, and ln of x is log base e of x, where e is called, some people call this Euler number, some people call this natural number. This is called 2.712. It's some kind of number that's defined by some weird limit or something. You don't really have to know at this point what this number is. Okay? Just know that on your calculator you have these two types. And in most calculators, unless it's very advanced, in most calculators, these are the only logs that you have. And if we need log base 2 or something, then you need to use some conversion formula called base change formula. Okay? And I'm going to teach you that later. Okay? That was quick. Okay. Now I still have a feeling that you don't know what log is, but think of this way. If you know how to compute a function, does that mean you know the function? I think yes, right? If you know how to compute the function, that means okay. So I'll just throw in a few questions and show you how to solve it, and then you're gonna immediately get the feeling that, oh, I know logs. Okay, so let's do that. The first question: number one, what's log base 2 of 8? Okay. Now we're gonna be using this mostly. Later on, we'll make use of this too. So we're gonna use this a lot. So if I want to use that, I have to first convert 8 as 2 to some power. 8 is 2 to what power? 3. 2 times 2 times 2 is 8, right? So 2 to the third power is 8. Okay, now what? What does it say? You can cancel, right? So you cancel it, what do you get? After canceling, what do you get? We just did that. After canceling, after applying this, what do you get? You get 3. You cancel log of 2 with this 2, what do you get? You get 3. That's what this is saying, right? You cancel, you get that, right? Okay, let's do another one. Log base 3 of 9. Okay, 9 is 3 to what power? Second power. Okay, so what's that?
2.
See? Now you know how to compute, right? It's easy, right? Yeah, okay. Yeah. See, it's not easier than saying, oh, log is an inverse function of the exponential function. It's much easier to work with these two. Right? Okay. Should I throw a curveball or should I?
Yeah.
Okay, curveball. Right. Okay, what would this be? All right, no cursing here. I'm recording. I can't even beep. Okay, so you have log 3 of 3 to what power?
3. Oh, I'm sorry.
Square root is what power?
3. 1/2.
Half power, yeah, exactly. Square root is same as half power, right? Okay, so what's the value? 1/2. Okay. Another one, log base 2 of 1. Uh-oh. Log 1 is 2 to what power? 0th power. Anything to the 0th power is 1. You knew that, right? Okay. So what's the value?
0.
Okay. 5 log 2 of 1 over 2. What's that? Yeah, exactly. 2 to the negative 1. Good. All right. So after doing these examples, I think you know logs. Can't you claim that you know logs?
Yeah.
Now you know logs.
We have to do
Okay.
You give us these.
Well, of course. Yeah, it's gonna. If it was just this, everyone would be passing pre-calc, except that's not the case. Oh, let me just do this last example, and then afterwards I'm gonna show you something
Get out of here.
more crazy. No, we're not getting out of here. More crazy. Uh-oh. What do we do here?
It's an inverse function.
Walk away.
Okay. You can't walk away. You can't drop the class. You have to graduate. Remember. Right. So 2 is 2 to the first power. Square root is 2 to what power? 1/2 power. Okay. If you have multiplication like that, what's that? If you have multiplication with same base, what do you do with exponents? You add, what's 1 plus 1 half? We use always improper fractions here, okay? 1.5 or 3 over 2, improper fractions, 3 over 2, okay? Right, you have 1 over some exponent. What's that same as?
Oh, it's negative.
2 to negative 3 over 2, right? Okay. So what's the final value? Exactly. Okay, so that last one was a bit more challenging, but basically this is it. This is what logs are.